Okay, so today we're going to be investigating flames. Please don't perform these experiments at home unless you have adult supervision. The experiments we're going to perform are going to use candles. We have three sorts of candles here. First, just see into this candle. This one's tea candles. Essentially, what's in this? Some matches to light them with. For combustion, we need three things. We need a candle. All three of these candles use wax extraction. So wax is a orange hydrocarbon. You also need oxygen. Oxygen here in the air. Some of those experiments will export some oxygen. And then the third thing we need is a source of ignition, which we're using a match to produce. We light these candles from each other just to let this is so once we start the candle by lighting the wick, it heats up the wax in the immediate area and melts that wax, that molten wax. That wicks up, comes up like a variation through the wick, and it's then vaporized by the heating flame, and that vaporized wax then starts to burn. So you get a nice area right at the base of the flame, close to the wick, which is completely transparent. The flame's completely transparent, that's a complete combustion going on. If you look at the yellow part of the flame, incomplete combustion. This is where particles of carbon in the flame are glowing, producing the yellow or white colour. Whereas close to the base of the wick, you get a small pool of flame. Right, so in this next video we're going to be looking at the vaporizing wax and the different parts of the candle flame. So we're going to start this by holding a candle on an angle instead of allowing it to stand straight up, and that's going to change the shape of the flames and accentuate some parts of it. What we could see before was a bright yellow flame, kind of like a spearhead. Now we've got a flame where towards the base of the flame, down by the wick, the flame is in contact with the wick at one end, and at the other edge of it, it's got this kind of triangular area which is completely transparent. Now what we know is the transparent areas are areas where complete combustion is going on. There is still combustion there, there is still vaporized wax being burnt, but in that area there's plenty of oxygen and that vaporized wax is being completely burnt. Further up, some of the vaporized wax is not being completely burnt and is causing the yellow flame, which has a different shape. Now one of the tasks for you is to draw the shape of the flame when it's like this. What I'm showing here is that if you put a wooden splint into this region between the what it looks like between the yellow flame and the candle stub, into this area of complete combustion, you'll see that it goes black, and when you pull it away, it's gotten sufficiently hot that as soon as you remove it, you can see that it's alight because there's the classic yellow flame with the glowing carbon particles making the yellow flame. Wooden splint. Now the next investigation we're going to do is look at the products of combustion. So the products of combustion, what gets produced when we burn the wax from the candle with the oxygen from the air. And so to do this, I'm just going to hold this glass jar over the top of the candle, and immediately what we'll see happen is that around the outer edge inside we can see this zone of moisture, condensation is formed around that outside edge. It doesn't happen in the middle of the jar because in that area the flame is directly heating the glass, but in this peripheral area near the edge of the bottom of the jar, I'm seeing moisture starting to condense on the glass. Now as well as that, if we look very carefully up in this area, we'll be able to see that there's some soot forming on the glass. So that's deposited carbon from unburnt wax, so where there's been incomplete combustion. The third experiment we're going to do is kind of like a nice little party trick. So we're going to see what it is that's actually burning in the candle, and we're going to do that by firstly I'm going to blow this candle out, and then I'm going to bring the other lit candle close to it, and you can see that the candle standing on the desk relit without the candle that I'm holding in my hand actually getting anywhere near
the wick of the candle that we're relighting. And what that shows you is that that column of smoke coming off the candle just after I blow it out is actually full of combustible material, and that combustible material is the wax vapor that's been wicked up, where the wax liquid has been wicked up by the wick, and it's been vaporized by the heat of the flame, and even after the flame goes out, the wick is still hot enough to produce vapor that is then able to be relit by my other candle. Now the last experiment we're going to do, we're going to look at extinguishers. Now a lot of fire extinguishers use carbon dioxide. We're going to do this experiment ourselves, and to start with, what we're going to do is make a situation that is conducive for this for us. So I'm going to mount a candle inside this jar. So what I'm doing here is melting some wax and puddling a little bit of wax on the bottom of the jar, and then I'm going to blow this candle out, pop it in there, hold it on that molten wax, and it will rapidly set, and now it's capable of being tilted up while I relight it. Now the next thing we're going to do is to create some carbon dioxide. And for that I'm going to use baking soda and white vinegar. I've got a little jar here. I'm going to put some of the baking soda on the bottom of this jar. Just a little more. Okay, some white baking soda on the bottom of the jar. Baking soda is reasonably cheap, household product, you should probably have it around. And some of this vinegar. And pop some of this in here, and immediately it starts to foam and fizzle up. Now we want to pour the produced, so that foam indicates that a gas is being produced. We want to pour the gas into the jar with our candle. But I think this one's actually producing so much foam and muck that it's pushing most of the gas out of the small jar and not leaving any in there for me to pour out into the larger jar with the candle in it. So I'm going to, you just saw it almost blow the candle out there with the carbon dioxide, but not quite. So I'm going to try this again. I'm going to find a larger container to use instead of this small jar. Now, keep in mind here, we're not trying to blow the candle out, we're trying to extinguish the flame by removing oxygen, by displacing or pushing the oxygen away and surrounding the candle instead, or the flame instead, the area of the flame, with carbon dioxide, which is not flammable or not usable in combustion of the wax. Okay, so I've put some baking soda into this plastic pot. Now I'm going to put in some white vinegar. And this is a much larger pot, so now I've got a pot that's much larger than my jar. It's producing plenty of bubbles there, and I think that will be good. I'm just going to try and leave it and let the bubbles settle. Maybe I should move it around, you never know, it might just end up expelling it. So I'm leaving it so that the hopefully the CO2, which is heavier than air, heavier than most of the components of air I should say, will settle. Oh, and I pour it in, and look, there we go. So as soon as I pour the CO2, you saw that you didn't see anything come out of the large pot, but I poured CO2 out and it extinguished the flame. Thank you for listening.